practices, and green innovations, inspiring community to connect with nature and learn about planetary health. CNAR, Special Needs Community Wellbeing Training and Research Center, a center dedicated to improving the
Buka video saya kan? Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, as we prepare to begin and introduce our esteemed speakers, we kindly request that you ensure your microphones remain on mute to guarantee a smooth and uninterrupted session. Should you have any questions or require technical assistance during the presentation, please utilize the chat box features on your screen. We will comment shortly. In the meantime, please enjoy the introductory video while we wait for all participants to log in.
The model integrates crop livestock systems.
In the heart of Kuantan, an institute of innovation and sustainability leads the way. Planetiium, a place where science meets purpose and ideas transform into action for a healthier planet. Planetiium began its journey in 2013 as the Ahmad. In the heart of Kuantan, an institute of innovation and sustainability leads the way. Planetiium, a place where science meets purpose and ideas transform into action for a healthier planet. Planetiium began its journey in 2013 as the Ahmad. Over the years, it grew into a center of excellence, expanding its scope and impact to address the world's most pressing challenges. Our vision is to be a top center for research and innovation in health, biodiversity, and climate change. Our mission is to work together across fields to create solutions that improve lives and protect the planet. With dedicated leadership, passionate researchers, and strong support teams, Planetiium works as one, united for a common purpose. Our research is guided by 4 pillars: food security, climate crisis, health empowerment, and biodiversity. Together, they form the foundation of our work. We are committed to the 4 R's: rescue, restore, reintegrate, and resurrect, as our approach to protecting life and ecosystems. Planetiium offers postgraduate opportunities, including the PhD and Master of Health Science programs, nurturing the next generation of researchers and leaders. We provide specialized services, from laboratory animal supply, research consultation and training, to environmental and health assessments. Our state-of-the-art facilities support cutting-edge research, equipped with modern laboratories, training spaces, and collaborative work areas. Through our internship programs, students gain real-world experience, hands-on skills, and the opportunity to contribute to impactful projects. Planetiium houses specialized research units, each dedicated to advancing knowledge and solutions in their respective fields. Frozen Zoo, a genetic resource bank that preserves the DNA and reproductive materials of endangered species, safeguarding biodiversity for future generations. Basics Biosphere Courtyard, an interactive space designed to showcase biodiversity, sustainable practices, and green innovations, inspiring community to connect with nature and learn about planetary health. CNAR, Special Needs Community Wellbeing Training and Research Center, a center dedicated to improving the lives of people with disabilities through research, training, and community support. Earthling, Educational Planetary Health Learning Program, an educational program that teaches children and youth about hygiene, health, and environmental care through fun, hands-on activities. Beyond the lab, we engage with communities through awareness campaigns, educational workshops, and volunteer programs, bringing science closer to the people. Our work is strengthened through collaborations with universities, industries, government agencies, and NGOs, both locally and internationally. From research breakthroughs to community impact, Planetiium has been recognized for excellence, innovation, and contribution to society. Planetiium, where science, innovation, and passion unite for a sustainable future. Together we make the planet a healthier place for all.
In the face of climate crisis and biodiversity loss, we ask ourselves, how can education institution lead the way in restoring our relationship with nature? PASIC, Biosphere Courtyard, is a living lab at Planetiium that empowers communities through agroecology, livestock integration, and environmental education. Our model integrates crop livestock systems, agroforestry, and circular practices that increase biodiversity, improve soil health, and reduce carbon footprint, all while benefiting local communities. We train future leaders, engage youth, and empower underprivileged communities to grow with nature, not against it. At BASIC, at Planetiium, we believe a nature-positive future starts with mindful action today. Together, let's grow sustainability from the roots.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Carmila and it is my absolute privilege to be your MC for today's event. A very warm welcome to all our distinguished speakers, participants, colleagues and students. On behalf of the Institute of Planetary Survival for Sustainable Wellbeing Planetiium at the International Islamic University Malaysia, we are truly delighted to have you with us for the Planetiium International Webinar Series, also known as SPACE. Thank you so much for taking the time to join us today. Before we officially begin our program, let us open our session by reciting Surah Al-Fatihah to seek blessings and pray for a smooth and fruitful webinar. We are thrilled to welcome you to our first webinar of 2026. Today's session officially launches the second year of our Planetiium webinar series Space, brought to you by the Institute of Planetary Survival for Sustainable Wellbeing Planetiium at the International Islamic University Malaysia. Building on this momentum, today's webinar continues our effort to bring together regional and international perspective, particularly within the Southeast Asian context, to better understand and respond to planetary health challenges. Last year, our discussion centered on the core pillars of planetary health, highlighting its relationship with biodiversity, climate change, food security, and health empowerment. Today, we are advancing that conversation to the critical role of IoT in planetary health. This session provides a platform to explore the application of IoT and smart system in Southeast Asia to combat climate-related challenges affecting our ecosystem and sustainable development. By bringing together cross-disciplinary experts, we aim to exchange knowledge and discover practical ways these technologies can monitor and mitigate environmental issues. Ultimately, we hope to inspire integrated solutions that protect our planet and enhance human well-being. Now, let us proceed to the main segment of today's webinar. Before we begin the presentations, I would like to highlight again a few important housekeeping notes. Each invited speakers will be given 40 minutes for their presentation. A Q&A session will be conducted at the end of all presentations. Participants are kindly requested to type their questions in the chat box throughout the webinar. Please mention the name of the speaker you are addressing your question to. Selected questions will be addressed during the Q&A session, subject to time availability. Thank you for your cooperation. We will now begin with our first speaker. Our first speaker is Dr. Pengiran Haji Azhan Pengiran Haji Ahmad from University Technology Brunei, Brunei Darussalam. Dr. Azhan Ahmad is an academic researcher and educator from University Technology Brunei, UTB. He is currently the program leader for the School Computing and Informatics Creative Computing Program, research leader for the Digital and Creativity Research Trust, and coordinator for the IDEA, Interactive Digital Experience and Advancement Lab at UTB. His interests are within the intersections of digital media and human-computer interaction, specializing in technologies such as end-user development tools, extended reality, and serious games, and they are used in various domains such as education and awareness. Dr. Azhan believed that these technologies can significantly impact society and can help address the interdisciplinary field of planetary health. He will be presenting on empowering society, democratizing smart technologies, tools, and data for effective planetary health initiatives. Please join me in welcoming Dr. Pengiran Haji Azhan Pengiran Haji Ahmad. Dr. Azhan, you can share your screen now.
Yeah, Assalamualaikum warahmatullahi wabarakatuh. Thank you, Nurul Karmila. Let me just share my uh, ah, Zoom. Okay. All right. Can everyone see the slide?
Can.
Okay, right. Thank you. All right. Good morning, everyone. So, as Nur Kamila has introduced, my name is Azhan Ahmad, lecturer from the Creative Computing School of Computing and Informatics, University Technology Brunei. So, as you might be aware that my area is essentially within the creative computing. So today, in my presentation, I'll be talking to you on how the society and various stakeholders can utilize interactive digital media tools and technologies specifically towards the planetary health initiatives. So before I start the presentation, I'm just going to introduce you to planetary health. I think some of you are not well versed in this area or may not be familiar with this term. So essentially, planetary health is all about cause and effect. Actions that people do to the environment can have some adverse effect to the environment, which can ultimately affect our health in some ways. So a good example is the haze that uh, we've experienced in ASEAN over the last decade. So the haze essentially is caused by farmers clearing the land by burning forests, which then caused some uncontrollable fire, and this caused haze to might reach the different regions in ASEAN, right? So the actions of the farmers essentially cause some degradation, adverse effect to the environment, which then affects the society's well-being. So that is essentially the focus, the concern with planetary health. We want to ensure that the planet and the society, the people living in it, is essentially, living in a healthy state, right? And it's basically concerning the three aspects, essentially, our activities and how it can affect the environment, which can consequently affect our health impact, right? So, uh, looking at this concept, this issue with relation in relation to planetary health, we want to cause some transformational changes to ensure that we achieve planetary health. But in order to do so, we need to understand some of the underlying drivers or factors that drives us our actions, which consequently will change the environment. So some of the drivers might include, our culture, the values and behavior of a particular community, because this essentially will drive their behaviors on the actions that they will typically do in relation to the environment. And we also another significant driver is what we is the consumption. How we consume the natural resources, and in order to produce marketable products and whatnot, right? And obviously the most apparent driver is population size. So as population increases, obviously we will need to make use of more resources, and this will then affect environmental changes as well. And finally, we need to look into the use of technologies as well, especially in terms of various industries. Uh, the technologies they use can impact the environment as well. So essentially, the goal of uh, planetary health is to shape these drivers towards positive changes. And in order to do so, we need to, as a society, globally, everyone, every stakeholders, a lot of different entities here need to come up with various solutions in order to, to address the negative impact that we can cause on in the environment. So there are various domains that we need to consider as well, because planetary health involves a lot of uh, layers of domains. It's not just one thing that we need to address, but a lot of a myriad domains. For example, we need to address the governance of how a particular institution to enforce, essentially to provide a guideline to carry out sustainable practices to ensure that activities done within a particular institution or country or community is well within aligned with the concept of sustainability and planetary health. And of course, we need to consider the use of technology as well, to ensure that the technology is, sustainable and can help us ensure environmental friendly approach in doing a lot of things. For example, in terms of manufacturing, we need to ensure the technology is eco-friendly, so to speak. Right. So of course, in terms of economics as well, and in terms of changing the values, changing the culture, the habits of consumers, and this usually relates to education. So education as well, I think from Planetiium, uh, that's one of the major approach that we need to address from the start to educate people, not just in terms of sustainable behaviors, but also in terms of how to uh, carry out suitable activities for different myriads of uh, 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 reasons. And obviously, research is another thing that we need to consider. So research is always going to be continuous. We need to look at the different uh, aspects in relation to planetary health and collaboration as well. Since planetary health involves a lot of stakeholders, we need to collaborate with a lot of stakeholders. For example, the public in general, the government employees, the government institutions, and the farmers, etc., etc. So through collaboration, this is where we can, produce sound solutions that can help address different problems in relation to planetary health. And on top of that, we also need to communicate the initiative or planetary health initiatives to educate people on what this initiative is all about and all the actions that needs to be done as well. And finally, of course, we need to be ready for any disaster that is caused by indirectly caused by the negative environmental effects that have caused, for example, in terms of pollution. We need to be ready on how to tackle all these kind of uh, problems. So my talk, I will be focusing on the use of interactive digital media and how this technology essentially can be utilized as intervention to help achieve planetary health. So, uh, interactive digital media is basically a subset of digital media, which is a opposite of physical media. All right, so you're accessing and utilizing media content through digital devices. So there are two types of digital media. The first one is what we call digital content. It's just digital information that we can access through social media, streaming services like YouTube and Instagram. And the other category is what we call the interactive technology. So things like games and extended reality goggles, VR, mixed reality, and augmented reality glasses. So I will be focusing on the use of interactive technology and how what role it can play within the context of planetary health. So, how can interactive digital media essentially be used in to achieve planetary health? I've identified four. Well, I'm just going to present four core fundamental roles that this technology can be used. The first one is in terms of monitoring, the environment and getting data from the environment, and then users can then utilize and make use of this data, which can then consequently be used for which they can consequently use to make decisions, and that goes to the second role of digital media, which is to help stakeholders make decisions. And then uh, the third the third reason why we want to use interactive digital media, which is the most obvious one, is to educate people. So education and awareness, as well as to train people on how to, carry out sustainable and eco-friendly behaviors or habits. And finally, obviously, digital media can also be used within the context of healthy lifestyle interventions, for example, to improve general health or mental well-being of people. So I'm going to focus on, so I will be presenting various initiatives uh, within the context of interactive digital media and how it has been used currently within these four components. So the first one is with regard to monitoring. So in this sense, digital media technologies, especially uh, extended reality technologies, are typically used coupled with Internet of Things system as well as artificial intelligence. So this is the first one is basically an augmented reality system that can be used to aid farmers in managing their indoor farm or outdoor farm. So in this system, basically, they are utilizing image object detection, which can uh, grab the video of the real world farm and then make use of image detection to identify the different types of crops within the farm, and then overlay information that essentially can be used by the farmers to help them manage the farm. And of course, in this example, and the screenshot here I'm showing, basically the type of information presented to the farmers, information about the plants, for example, the first fertilizers being used, the type of plant, the growth cycle of the plants and whatnot. So this system is connected to the IoT sensors installed in the farm, and so users for this system basically they they make use of AR glasses, which utilizes not just image detection but also uh, uh, I mean audio input, which they can use to interact with the system to get more information. Uh, Another example is a system, an AR system, which utilizes image machine learning model in order to detect diseases and pests that can grow on paddy plantation. So basically, this system is used by the farmers in order to quickly survey their paddy plantation and to make sure that the plants are healthy and no detectable diseases or pests. And so this system is also utilizing AI, machine learning, image machine learning model, and as well as audio input. So the multimodal that they use in the system uh, generally can create a more accurate output to the farmers, and essentially can help them, efficiently manage the paddy field. Because basically, if you're using a manual detection, a survey of the paddy plant, obviously it's going to take a long time. But utilizing AR and camera image recognition, it's going to it's going to help the farmer expedite the process of surveying their plantation. This one is another example, similar to the paddy field, is basically utilizing machine image detection machine learning model to quickly detect the different types of plants. And this is in this system by Ziedler. They're also utilizing IoT sensors measuring the different environmental status of the indoor farm, such as the temperature, the ambience, the ambient of the room, the soil acidity and whatnot, etc. So this information can then be displayed on the AR glasses. So again, in this system by Ziedler, it's actually a system utilized to be implemented in a space station. So the aim of the system is basically to help the astronauts to maintain and manage the crops, the plantations in the space station. So the system essentially will provide them with the expert review on the fly in real time. So it helps the astronauts who might not really be familiar with the stages of the plants. So this can help them, manage the growth of the plant. And then finally, in terms of monitoring examples, this one, Spiro, is a digital twin implementation. So in this project, they essentially have created a digital twin, so a virtual representation of a real world indoor farm. So basically, what that means is that they have a physical indoor farm somewhere installed with various kinds of sensors. And this system allows users to uh, manage the indoor farm through virtual reality. So they're actually they're actually exploring a virtual world, which is an actual one-to-one representation of the physical farm, which might be set up somewhere else. So through this system, the application are also connected to IoT sensors installed in the farm. So it feeds back real-time data from the farm and is reflected in the virtual reality wall. So a person from a different country can essentially, view the farm in virtual reality and view the different types of information. For example, the temperature of the room, the status of the plants, the water levels and whatnot. All right. So this kind of system will allow the remote operator to control some aspect of the farm. For example, controlling the temperature of the room, controlling the lightings and whatnot, right? So essentially, utilizing these three different technologies: IoT, artificial intelligence, uh, and int extended reality devices. We can utilize this to present users with real-time data, and we can use it, visualize it meaningfully, and this can help and achieve and promote precision farming, right? And this will consequently then help minimize resource waste. For example, the system can tell the farmer exactly what is needed to cultivate the plant, to make sure that the plant is growing healthy. So, it basically enables them to carry out the proper procedures, right? And of course, obviously, the data can also encourage sustainable practices. And the next uh, decision making. So obviously, in the previous slide, we were talking about how virtual extended reality devices can be used to present information to users. Now, this information obviously can be used to guide the users in making decisions. All right, so that's one way digital media technologies can be used within the context of planetary health as well. So some of the examples here relates to the first one here relates to the use of computer graphics and simulation models, which can help users plan better. All right. So where Lasso basically develop a virtual reality system which replicates a piece of land in New Zealand, which is based on uh, real data, so real terrain. And in this application, the farmers can essentially manage the area. For example, they can plant trees in specific areas. And what the system does is that it has specific simulation models. They have weather simulation model, and they have economics, financial simulation models as well. So what the farmers can essentially do is they can, decide one day, okay, I want to plant particular trees around this area, and then the system can then generate and predict what's going to happen, to the environment when they do this kind of actions. And then it can also provide the farmers with forecasting on the financial profit and loss caused by doing this action. So this will provide and will help the farmers make an informed decision before they can actually implement it in the real world, because obviously this is going to save a lot of money on their part. So that is one example on how virtual reality and forecasting models can be utilized to help users make decisions that can, ultimately affect the environment. And another example here is it's a augmented reality application which can help farmers cut certain uh, uh, things on the it's a vineyard. This is a grape vineyard, so in Europe. So I think that's the those bit here is something that is not healthy for the tree because it can cause, I don't know, infection to the tree. Basically, farmers need to cut this part to ensure that the grape vineyard can grow healthy and produce, quality grapes. So but of course it requires expertise and skills in order to cut this part of the tree. So Haring and his team basically developed an augmented reality application that basically takes into account the different camera angles and produces a guide layout on where to cut around this part. So this can help people, the farmers essentially, or the people working at the farm to cut the part effectively and efficiently. And then this one is another example in livestock management. So this system is utilizing augmented reality as well as artificial intelligence, specifically uh, image detection model. So this one in this system, basically it helps the farmer to identify cows in heat, essentially to ensure that to identify whether a cow is ready to be to conceive new babies. So in the system, basically the augmented reality application is able to identify two things. The first is the system is able to identify individual cows, so they know which cow is which cow. So this is as opposed to using individual tags, you typically see on cows where they usually place the tags on the ears or whatnot, or maybe RFID, right? So by utilizing image detection, to be able to identify the different type of cows. Obviously, this is going to provide a very quick way for the farmers to manage a farm effectively, efficiently. And the other thing that the system can do is to detect whether a particular cow is ready to conceive. So why is this good? And why is this really beneficial? Uh, because it helps the farmers identify, if they are able to identify a particular cow is ready to conceive, they can then carry out the necessary actions to ensure that the cow can actually conceive and uh, have a new calves. Because in manual process, without this kind of system, usually they might miss several cows that are ready to conceive, and in doing so, the cows might not be able to give birth. So this will result in loss for the farm because, first of all, there's going to be a reduction in milk production, and there won't be any new calves. So and they're gonna then have to wait for another several weeks before the cow are ready to conceive again. So by having this system, they can ensure that they fully maximize uh, the reproduction cycle in cows. So in this example, we have shown, how different technologies, again, in terms of computer graphics, simulation, and artificial intelligence, machine learning, can be utilized within the context with digital media technologies. So the next one is looking into education, and as I mentioned earlier, this is uh, 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 the most obvious area where digital media, especially in terms of extended reality, and obviously gaming as well, can be utilized. Now, obviously, when addressing planetary health, we want to educate people. We want to educate the younger generations and the different public, and obviously even the professionals and the industry on how to inculcate sustainable activities and habits and behaviors in them. So there have been many examples on how games have been utilized to educate the public. So this is just an example of a simple game. I mean, like there are lots of games out there focusing on sustainability and planetary health. So this is just one example. It's from New Zealand. It's just a simple game, but in this game, basically players are making choices in relation to the environment. In this example, is specifically a beach in New Zealand. So essentially, they'll be doing things to change the environment, and then the game will then, showcase what is going to change to the beach when you do something, right? So it's a cause and effect. So it's in a way to educate them on, if you do this, this is going to happen, and also it's going to create awareness on people, all right? And this one by Nguyen, it's basically a virtual reality application where people can explore a real cow farm. All right, so this is to create an awareness as well, to bridge the gap between public and the farms, to ensure that to educate the public that the farm is exercising uh, uh, sustainable practices in cow herding and rearing. And this too is a very important uh, studies looking into how virtual reality can actually impact us and change our mindset, right? So this first Ann Bayliss and Park. Basically, in the study, they've developed a prototype virtual reality where users are basically asked to cut a tree using a chainsaw, right? So in this experiment, they found out that but by doing this experiment, users somehow after several weeks they reduced the use of paper by 20%. So now a little bit of context. In the virtual reality, the players are situated in a forest and they're holding a chainsaw. And in the beginning of the scene, basically the users can hear the sound of the forest, birds chirping, sound of the wind, etc., etc. Right? And then they were encouraged to obviously look around, see the beautiful view and whatnot. And then suddenly the users are asked to cut the tree. So they're cutting the tree for several minutes using the controllers in the virtual reality, and they can actually feel the feedback from the action, right? And then once the tree fell, they hear a loud crash and everything changes. There's no ambience anymore. There's no ambient sound anymore. There's no birds chirping, right? So it basically becomes gloomy, right? So this basically it builds empathy in users. They feel like, oh, I've just got a tree. I've just done something bad, right? So they're changing their habit and behaviors and perception of the participants, right? And similarly with this one experiment, now, in this experiment, basically, it's the same team. They've created a virtual reality where the users uh, they become a cow, basically. So, in order to move around the virtual world, they have to, crouch on all four limbs, and they have to role play as a cow. So they're controlling the cow in the virtual reality while moving around in the real world. And in this scene, in this system, in this experiment, they can actually see themselves as a cow, and the researchers periodically will you know, prod them with sticks. So, as if like they're in a farm and people are prodding the real cow. And so that feeling creates not they don't feel nice essentially. So they basically uh assume the role of a cow, and they feel like they they are the cow, and it feels empathy on them. All right, so they feel like it's not nice being treated like this, right? So those are some of the just examples on how interactive digital media are powerful drivers to educate, create awareness, and also to change your perspective and perception of the world. Right, and finally, we're going to look into how interactive digital application is also used within the context of health. Because health is obviously the main component in planetary health, because we want to keep the planet healthy, which consequently makes us healthy, because that's the focus, really, our health. And and there are various examples of how interactive digital media are also used within the context of a human's health and well-being. So this is an example of an application from our own Idea Lab. So we have developed an exagame, a cycling exagame, to inculcate and to motivate healthy lifestyle in participants. So, and from this experiment, we can see that people are motivated to play exagames, perform to complete the quest, right? So we can see that utilizing games is a very good uh, device to motivate people to live a healthier and active lifestyle. All right. So there are various other exagames being used within this context as well. For example, commercial Microsoft Kinect adventures. Microsoft Kinect titles has always been used within the context of uh, exagame research, and various exagame research have actually shown that using games for exercise can actually improve various health-related measures. It makes you happy. It reduces stress. It reduces depression. Yeah. But on top of that, they also help it can also improve physical health-related issues. For example, stroke patients, and rehabilitation of the body part, the limbs in patients. So this is one example of a game, I Am Dolphin. So in this game, it's a virtual reality game. So in this game is actually used for rehabilitating muscle injuries, or I think limb injuries, something like that, right? So the participants will essentially wear an exoskeleton device on their arm. I think it's to rehabilitate their arm. So they're using this device, and in order to move the dolphin around, they have to move their hand in a particular order, a particular exercise regime. So, so they'll be using they'll be interacting with the game wall by doing that kind of actions in order to navigate the dolphin in the virtual wall, and it has been shown to be effective in helping people rehabilitate and improve from the current health issues, right? So those are just some of the examples on how interactive digital media, coupled with other technologies, specifically IoT and artificial intelligence and 3D simulations, can be used as different interventions for the different domains to help achieve planetary health. So I end my presentation. So I'm just wondering if well, it's Q&A session, I think.
Thank you, Dr. Azhan, for that comprehensive and insightful presentation. Now we open the floor for Q&A session. Participants may unmute your microphones and ask directly or via the chat box. Allow me to read the question through the chat box. Thank you, Dr. Azhan, for the sharing. It's very refreshing to learn the high technology in precision farming. What are your recommendations to reduce the cost of this technology so that it can be more affordable to small-scale farmers who has limited natural resources such as land, water, and sunlight indoor farming but wish to maximize their harvest?
Yeah, so essentially, this one is within the realms of IoT, and naturally, you would need IoT devices. But of course, I think uh, there are lots of manufacturers creating IoT devices which are generally cheap. But of course, you would need developers to develop the system, and that might be costly as well. So one issue with this, one approach with this is to utilize uh, smartphones and artificial intelligence, and specifically image recognition. Uh, yeah, that's one way of uh, addressing that. Ah, yes. Well, the issue of AI is beneficial, but at the same time, detrimental to the environment. Well, currently there are low footprint AI models. For example, Llama, which is very lightweight and it can run on your smartphones, and it doesn't really need, high computing power to run. So that is probably one of the approach that we can look into the future, and especially to address the small and medium farmers.
I also
Did that
have
answer the
a
question?
question to Dr. Azhan regarding the decision making presented. How do we ensure the accuracy and reliability of data used in AI models to support decision making?
Yes, so some of the examples that I shared with you, they rely on training the AI model beforehand, and usually they're specific to a particular data set. So, for example, in terms of paddy recognition, they need to get data set on paddy, and naturally this would probably need to be from local data set as well. Uh, but basically the quality of the recommendation obviously comes from the quality of your data. And secondly, uh, some of the systems are utilizing IoT devices. So these are the data comes from the sensors as well. So we can assume that the data coming from the IoT are accurate enough, right? And lastly, obviously, it's the model that analyzes the data and produces recommendation to the farmers. So this one obviously needs to be researched on. Okay. At the end of the day, it's all about collaboration between not just the researcher and developer, but also with the target end user, right? So we need to ensure that we get what the users really need and what they require.
Okay, thank you, Dr. Azhan. Now we move on to the second speaker. Please welcome our second speaker, Associate Professor, Technologist, Dr. Siti Hajar Yusoff. Dr. Siti Hajar Yusoff is known for her contributions to sustainable renewable energy systems and academic internationalization. A former student of College Yayasan UEM, KUEM, Lembah Beringin, she obtained her Master of Engineering, first class honors in Electrical Engineering, and her Doctor of Philosophy in Electrical and Electronic Engineering from the University of Nottingham, United Kingdom. She joined the Department of Electrical and Computer Engineering, International Islamic University Malaysia in 2015, where she now serves as an associate professor. Her expertise lies in the control of power electronics and electrical power system, particularly in power converters and drives, matrix and multi-level converters, Internet of Things, smart metering, wireless power transfer for dynamic charging of electric vehicles, EVs, and renewable energy system. Dr. Siti Hajar has secured a total of more than 1 million in research funding through national and international collaborations. Her outstanding work has earned her several recognitions, including the 2025 Most Prestigious International Grant Award by Persatuan Saintis Muslim Malaysia, Perintis, currently serving as Deputy Director, Collaborations and Mobility at the Office of International Affairs IIUM. She plays a pivotal role in establishing strategic partnerships and strengthening IIUM's international footprint in research and academic collaborations. Her session will focus on smart engineering solution for planetary health, IoT applications in energy and waste management. Let us warmly welcome Associate Professor, Technologist Dr. Siti Hajar Yusoff. Dr. Siti Hajar, you are welcome to share your screen.
Thank you so much, Camila, for the introductory. Let me share my screen. Okay, Assalamualaikum and a very good morning to everyone. So it's almost midday, isn't it? Halfway through. Okay, so just bear with me. I will be talking about a smart engineering solution for planetary health, IoT application in energy and waste management. So today's talk will consist of two, actually. I will talk, one part of my talk will be on the smart meter, which is energy system. And then the other half will be on the waste system. So we will talk about automatic metal waste separator system. And basically, this is my roadmap of presentation for today. We will go through why planetary health needs engineering action, and then the energy system and also the waste system. Why planetary health needs engineering actions? So it's a big question. Energy. Everyone use energy, isn't it? So energy nowadays power our electric vehicles, our home, and then without energy, we cannot survive. For example, can you imagine living in the darkness without light, without electricity at your home? No, it's impossible, isn't it? So we actually this energy affect the planet through our consumptions, the gas emissions, the carbon emissions, and the resource use. And the waste. Waste is something that is not wanted. So that's why it's called waste. And it's actually polluting our planet. It's giving the landfill pressure and it's a loss of valuable materials. So both of these issues, energy and waste, is actually influence our environmental quality, public health, and also our future sustainability. So here comes the engineers of the future. So we, the engineers, we have to create something that's sustainable for everyone. So in order to improve the energy, the waste system to support our planetary health. So this slide, so here where my talk will actually divide. The first session will be on the energy system and the half session will be on the waste system. So for the energy system, the IoT itself, okay, Internet of Things, smart meter shows how real monitoring can help users understand and manage electricity consumption more effectively. So for the waste, the automatic metal waste separator show how engineering can improve recycling through automated sorting. So together, energy and waste These are the examples that highlights how engineering can contribute to planetary health by improving the way we monitor, manage, and recover resources. So why smart meter is important? Okay, let me ask, how many of us actually has smart meter at their home? Anyone? Is it almost everybody? I believe like most of houses in Kuala Lumpur and Selangor, the Tenaga Nasional Berhad already converted the conventional meter to the smart meter, right? I believe. So for those who still with the conventional meter, you can call up Tenaga Nasional Berhad, I believe, to convert to the smart meter. Why smart meter is important? So you can see the figures here. So Malaysia total electricity production in 2023 was about 193 gigawatt hour, and the trend shows an 179 increase from 2000 to 2023. So the main source of electricity generation in Malaysia is still coal, about 45%, and natural gas, about 35%. So this tells us two things. First, electricity demands continue to grow significantly. Second, much of our electricity generation is still dependent on conventional resources. So as demand increase, it becomes more challenging to manage power consumptions efficiently and monitor usage accurately. So this will reduce unnecessary waste. So this is where the smart meter is relevant. Why? Because it helps make the electricity more visible in real time. So you can monitor the electricity usage in the real time. You improve the monitoring, and at the same time, you know the current state of how much your house already use the electricity. So if you are, I mean, in the budget cut, for example, you need to reduce the consumption of electricity. So using a smart meter will really help you in terms of your expenses. So you can see here, so in this way of smarter and more sustainable energy system, which align with Transformasi Nasional Malaysia. So this is a long-term development directions. So let's move to the first case study, IoT smart meter. So unlike the conventional meter, okay, the conventional meter, we used to have the TNB guy coming to your house every month, collecting the reading, mechanical reading and manual reading, and then give you the paper bill, right? So if you still remember, every month you will see this guy popping up at your house. So during the COVID era, where you cannot freely go outside. So this guy, during the COVID era, you cannot freely go out, and then you only can work from home. But this guy has to go to your house and still taking the electricity bills. So what you can tell that this mechanical reading and manual collections is more like very one way. So now we have smart meters. We're utilizing two ways of communication. So one direction is between the meter and you, the user, which allow you to actually monitor your electricity usage. So it can monitor every day. So you can have a very like daily consumptions. You can know that today you use how many kilowatt hour. So, and the other direction is between the meter and the utility provider. So the TNB can also knows your electricity usage, which this allow data being transmitted more systematically. So overall, this energy management process can be more efficient. So smart meters can actually automate procedure, provide real-time data on operational efficiency. So this can reduce dependence on manual manometer reading, which saves time and also human resources. So as simple term, the smart meter is not just a measuring device, but a smarter platform for energy awareness, control, and decision making. So in the next slide, I'm presenting to you the architecture, the operational flow of the smart meter system. So the process begins with the electrical load here. So the load can be anything. For example, here I put a plug. So the plug can be plugged into a lamp, lights, and can also be your laptop, for example, or the fan. And then where we have here the PZM004T, the sensor, which measure the key electrical parameters such as the voltage, current, and power factor. And these measurements are sent to the Arduino Mega, which act as the main controller of the system. From here, okay, we have ESP8266 Wi-Fi module, which transmit the data to our Blink app. So the Blink app here is the IoT cloud-based. So we use the Blink app, allowing the user to monitor energy consumption remotely in real time. So we have also the LCD display, the measured value locally for immediate viewing. So for example, you can view your current electricity bills in the using the LCD. So it gives you the current consumption of your house usage. Okay, so if, for example, abnormality happen, for example, you have set your house for a certain limit, and then suddenly you surpass that limit. So what will happen is you will get a notification through the billing apps. So this will alert the user, and then the user can take. Okay, so not just having an alert, so you can also respond to the alert by remotely. Okay, so for example, you say that okay, you already surpassed the limit of your budget, so you say that you want to cut off the aircon. Okay, currently the aircon is on at your house, for example, and then you just remotely send through the apps. You send and say that okay, stop the aircon. So it will stop the electricity supply to the aircon, and the aircon automatically switch off. So this flow shows how the sensing, from the processing, communications, and the user feedback, which control and integrate the IoT based energy monitoring system. So the relay here actually that put the cut off to your to your load. Okay, so in this slide at the top, we can see here the physical setup, okay, of the proposed prototype from my student. So this is including the outer view and the internal hardware arrangement. So the system is connected to the load. So the load here is the lamp, okay, and electrical parameters such as voltage, current, and are measured, okay, and displayed through the smart meter setup. So here, the bottom image, you can see the Blink mobile application apps. So being used to monitor the system in real time. So you can actually use the mobile apps to dim, to adjust the light intensity remotely. So you don't have to go to the light bulb to actually adjust the light intensity, but instead you can use just your phone, the mobile apps, to remotely adjust the intensity of your light. So you can go dimmer or you can go more more intense. So here it shows that the system not just collecting the data, but it allows the user to respond as well. Okay. So for this one, you can see that, okay, here's more of the snapshot of the mobile apps notifications. Okay, so for example, here the energy consumption has sparked. So for example, if you set the maximum limit of energy usage at your home about 20 kilowatt per day, for example. So 20 kilowatt per day is suitable for family of 3 to 4 people. And this cover of daily appliances such as fridge, lights, washing machine, TV, laptop, and if you on aircons, moderate use of aircon. So it's about 20 kilowatt per hour per day. Okay, so For example, if you set the limit as 20 kilowatt hour per day and it surpassed that, so you will get a notification saying that, okay, the energy consumption already sparked, means that you already exceed your budget. So, so the apps ask you, send you an alert and ask you whether you want to do anything about it, or if you don't want to do anything, you can just, remain the load as it is, but you already know that your budget already exceeded. So that is the useful of this system. So you can remotely control your device and everything under one platform, IoT. So, so in here, you can see that from the smart meter prototype, it connects to a wider planetary health relevance. Okay, the first function is sense. So the system measure key electrical parameter, voltage, current, power factor, energy consumptions. And the second function is to inform. These data are then displayed in real time through the LCD and the mobile apps, giving users immediate visibility of their electricity usage. And the third function is to influence. Once users are informed, they can respond by taking actions. So such as switching off the load or adjusting the appliance, or do nothing. It's up to the user. So this lead to the final stage, the system benefit. So by combining sensing, feedback control, the smart meter can help reduce the waste energy. It also improves the user awareness and supports smarter demand management. So by broader point, the prototype is not only a monitoring tool, but a practical example of how IoT can create environmental value through visibility, feedback, and control. So in the next slide, I will move on to the second part of my talk. We will now go on the waste system. So how many of you know that, okay, in general, we deal with waste every day. Household waste is a lot, isn't it? Malaysia waste is mostly wet, so it's make it hard to recycle a household waste. Okay, but today's talk, we're going to talk only on metal waste. We're going to focus on metal waste in Malaysia. Metal waste remains an important environmental and resource recovery issue in Malaysia. And it's quite environmental concern. Okay, so based on 2024 report, it says that about 262,000 tons of metal waste were generated, okay, in Malaysia, which represent about 19.9% increase compared to 2023. That's a lot. It's about 20% increase in a year. So this rising trend shows that the challenge is becoming more significant, and the conventional waste handling approach may no longer be sufficient in the future. So at the same time, metal is a valuable materials, so which simply should not end up at the landfill. Okay, so this is why Malaysia needs a smarter waste management solutions, especially the one that can improve the sorting, recovery, and recycling efficiency. So in the next context of my talk, I would touch on the engineering solution such as automated waste separation, which really play a meaningful role. And before I actually go on into my automated waste sorter, so let's actually look into what is a circular economy. It's a very important concept when discussing about sustainability and planetary health. In the traditional economy, okay, which is a linear economy, we usually follow the pattern to take, make, and dispose. Means that we buy the product, we use the product, and we dispose the product, isn't it? So this is a linear economy, which means that the resources is being extract, used, and discard as a waste. So in a contrast, we have a circular economy which actually aims to keep the material. So we buy, we use, and after we use it, we recycle it to make it into another product that can be used. So instead of having a single life, so the product can have a multiple life. So for example, you can see here in my slide, I shows to you the recycled paper wrapper. So it can be used as a packaging now, and the woods, the wooden. So we use, instead of using a standard steel, we use a wooden utensils, and then we recycle our organics and inorganic waste, and we use a reusable feminine hygiene pad. So this is what circular economy about: reduce, reuse, and we recycle. So in the context of this talk, smart engineering solutions support the circular economy by improving how we monitor resources, we sort the waste, and we recover materials more effectively. Engineering challenge behind the smart waste. Okay, management. So as the waste volume continues to increase, okay, existing system face greater pressure in terms of collection, sorting, and disposal. So one major issue is that manual sorting is often so slow and is very labor intensive, and the sorting can be inconsistent, and it can be also difficult to scale, okay, because the volume of the waste is becoming larger. So this affects both efficiency and the quality of the material recovery. So from an engineering perspective, so this can create a better opportunity through a smarter solutions. So by introducing sensing, automations, okay, and simple data system, we can improve waste classification, increase the sorting speed, recover more valuable materials, and record for monitoring and future decision making. So why data recording and monitoring is very important? For example, this data is crucial because you want to do a predictions of your waste in the next 5 years, for example. So without the current data, without the past data of how how many tons of waste get generated per year, it's going to be difficult for us to estimate or predict the next future waste. So this data recording and monitoring is very important. So next talk. Okay, next slide. So I'm showing to you the automatic metal waste separator system that we actually done in our lab. So this is basically the solid work photo diagram of the automatic metal waste separator. So you can see here the prototype was designed to automate the sorting of recyclable household waste into different categories. Okay, so the core of the system are the main elements. Okay, we have sensors. Okay, we have servo motor, and then the microcontroller, which is inside the conveyor belt. So it's underneath the conveyor belt. So the sensors are responsible for detecting the types of materials. The servo motor carry out the physical sorting actions. So the servo motor will push the pusher here. Okay, so the pusher will push the materials, okay, to the recycling bin. So here we have aluminum bin, we have copper bin, and we have also steel bin and non-metal bin. Right? So you can see here, this is the conveyor belt. Okay, so the material would be disposed from the top, and then it will go through the conveyor belt. So based on the sensor input, the system will separate it accordingly to the bin. Okay, So this prototype demonstrates how a relative simple embedded system can be used to improve waste separation in a more automated and systematic way. So for this project, we actually classify it to four main classification of recyclable household waste, which are non-metal, steel, aluminium, and copper. So for non-metal items such as plastic bottles, containers, first identified, okay, and separated to avoid contaminations of recyclable metal streams. So steel is then detected through its magnetic property using the rotating bar magnet, which make it possible to separate ferrous materials such as food can and milk tin. So aluminium, which is lightweight and commonly found in beverage cans, is identified after excluding the steel, and copper is then directed into aluminum container. So copper is identified using a color sensor, which based through its distinctive reddish brown color. So it's sorted into a copper container. So this qualification process is important because it's not just improve sorting efficiency, but it support the better recycling. And at the same time, it's also increase the recovery value of different materials. In this slide, the architecture and operational flow of the waste separation system begins, okay, by using an inductive sensor, which actually um, detect, okay? So it checks the items, whether the item is metal or non-metal. If it's non-metal, it will be directed to a non-metal container. So using the pusher, so it will push the non-metal item, for example, the plastic. So if it's a metal, the item will continue to the next stage. So the rotating bar magnet here, okay, is used to identify steel based on its magnetic property. So if the item is not steel, it moves to the next color sensor, where here it identifies whether it detects copper based on the reddish color on the copper. So if it's not, okay, if it's not copper, so the final inductive sensor will sense, okay, whether at this stage, okay, so we want to isolate the aluminum. So throughout this process, we use the Arduino Mega microcontroller so to receive the sensor's input and sending command to our four servo motors here, which these servo motors will direct the items into the correct container. Okay, so as I mentioned just now, okay, we have four containers which are non-metal, steel, and copper, and also aluminum. So at the same time, we use a micro SD card to record the data for monitoring and record keeping. So this how we show the sensing, decision making, actuations, and data storage work together in one integrated sorting system. And here you can see, okay, on the left side, okay, of the circuit, here is the circuit. So how the different components are connected through the Arduino Mega. So you can see that the sensors, inductive sensors, color sensors, micro SD module, electronic, ultrasonic sensors as well, and also the servos. So in this slide, you can see the inductive sensor. So the importance of the inductive sensor is it detects the presence of the metal without the contact, and it can distinguish by sensing the response. And the rotating bar, so this is what that actually magnetic, okay? So it actually can, attract steel. So through the magnet, we actually extract the steel from the conveyor, okay? All right, and then the color sensor, which identify our copper, and the ultrasonic sensor, which actually counts all the items that have been deposited to the bin. So here shows the prototype implementations of the automatic meterways. So here's more of the zoom of the prototype. Okay, so here's the separator bin. Okay, we have all the 4 bins here, and then you have the conveyor belt. So at the top here, where you actually dispose the all recycle materials, and then you have you have also the pusher. So the pusher is the one that push the items to the bins, the respective bins, and it's all operated using a 12-volt DC motor. And then ultrasonic sensor is also placed in the bin to actually count the number of materials being deposited to each of the bins. Okay, so here the summaries of the main function, okay, of the waste separator prototype using a 4-stage logic. So the first is the sense. So inductive, color, and ultrasonic sensor generate digital input events by detecting material properties and item presence. So second is decide. So the Arduino Mega process these inputs, okay, and execute the classification logic locally at the edge, determine what type of material is being handled. So the third hack is based on that decisions, the servo motor and the conveyor mechanism translate the logic into physical sorting by directing the item into the correct bin. And the last but not least is the store. Okay, so the micro SD login function records the collected count, creating a simple data layer that can later support monitoring, dashboard, and future analysis. So this slide is very useful because it shows that the prototype is not just a mechanical sorter, but a complete embedded workflow involving sensing, decision making, actuations, and also data storage. So here is the examples, okay? So show how the accurate is the material sorting based on the test items used. So in this test, we use a bottle plastic, a drink can, okay, a milk tin, food can, which actually been detected. So a bottle, non-metal, drink can, aluminium, milk tin and food can is detected as a steel, and a Milo can is aluminium, sardine, steel, and copper wire in the copper. So you can see here the micro SD card already detects and count the number for each of the items. Okay, and the conveyor here is actually 30 degrees inclined so that it will sort, it will not just sort, it will actually roll the material easily and close to the sensor. Okay, so I would like to ask everyone, okay, to watch a video of the prototypes in actions. So let me try. Okay. I'm trying to play the video, but it looks like okay, all right. Okay, I hope you can see the video. So that is the copper. So the data is saved in the SD card. Okay, right. Although this project is a small prototype, it's just um, pioneer project prototype, but they demonstrate a meaningful sustainability value. The smart meter shows how real-time monitoring can improve energy awareness, user control, and household efficiency. So the waste sorter shows how sensor-based automation can support better waste separations and material recovery. So together, so this example highlight an important message in both energy and waste management, better visibility, monitoring, control, and essentials. So more broadly, they show how IoT and embedded system can help bridge the gap between awareness and action in sustainability. Before I end my today's talk, so I would like to call up everyone, okay? So if engineering, okay, without engineering, um, we will not be able to have a sustainable solutions. So engineering contribute meaningfully to planetary health, and it meets three important qualities. So the first qualities, so they must have engineering must have must be smart enough to sense and respond, meaning that they can detect condition, generate useful information, and support timely actions. Second, engineering, okay, must be practical enough to be implemented because sustainability solution need to work not only in theory but also in real system and real communities. Third, they must be sustainable enough to reduce environmental burden, whether through lower energy waste, better resource recovery, or more efficient system design. So this slide reminds us that engineering for planetary health is not only about innovation, but about creating solutions that are intelligent, applicable, and responsible. And with that, I would like to end my today's talk. And thank you very much for your time. And also, I welcome any questions from the audience. Thank you very much.
Thank you, Dr. Siti Hajar, for the informative and thought-provoking presentation. Now we open the floor for Q&A session. Participants may unmute your microphone and ask directly or via the chat box. For the first question,
I-
for,
I
for
believe
the
everyone is
waste,
tired or looking forward for lunch.
for the waste separation system, can a color sensor still detect copper if the surface is dirty or the original color is not visible? Does other sensors can support color sensor?
Okay, very good question. Thank you very much. Okay, so different sensors has different specifications. Okay, so for examples, if you are saying whether inductive sensors can actually detect colors, unfortunately no, is because only because with the color sensors, okay, so whenever it detects a color, uh, let's go back to the slide. Okay, so for the color sensor, we use this chip. So with this color sensor, okay, whenever we detect any materials, so we will reflect the light back to the sensor. So if you can see the LEDs here, okay, so it will reflect the light. So it will every time it senses a material, so it will reflect the light. So through the sensor, it will sense the color. So the color has a different code. So for here, we actually, for copper, so we have set for copper code. So for example, okay, if the material is a bit like out of color, okay, so unfortunately, okay, the color sensor will not be able to detect. Okay, but because we have the other screening from the other inductive sensor, so we know that, so that's why we put the copper towards the end. So we know that, okay, first is not non-metal, okay, so it get past the first phase, so then it will go through the inductive sensor. So if the inductive sensor doesn't sense, okay, that is metal, so what happened that it will get passed through. So okay, so if the color sensor fail, so what happened, it will fall out to the last bin, so it become non-classified. Okay, so but for today's presentation, we didn't show that. So that what actually happened. Yeah.
For next question, my question is, how do we ensure that smart waste technologies actually reduce waste rather than just improve how we manage it?
Okay, right. So may I read that again? Sorry.
How do we ensure that smart waste technologies actually reduce waste rather than just improve how we manage it?
Okay, right. So, right. So basically, data is number one. So without a data, we will not be able to estimate how much waste produced in the next 5 to 10 years. So if we cannot predict, so what will happen? For example, our waste management. Our waste management will not be able to actually has a timely plan. So, is timely plan how we gonna dispose all this waste. So, in this method, okay, first is the data. So through the data, we know that okay, in the next 5 years, we're gonna have like 30 to 40% increase in the waste. So with this, the waste municipal has plenty of time to actually plan ahead the next 5 years. We need to have enough landfill to cover all this waste and enough exit plan, enough time for the exit plan. So number one is the data. So second, so with the okay, so at the moment, what happened is the trash truck. Okay, the trash truck will come to your house and collect all your waste, and then they will go to the central, and then will dispose all your waste in the landfill, dedicated landfill. So that's what actually happens. So and then we have people who do the sorting. So what happened now? Even the metal. So for example, now you can see that in your household. Okay, so you dump everything, right? Today I want to cook a sardine. Okay, sardine dish, and then you open the sardine can, and then you throw the sardine can in the bin together with your other household waste. So it can be a banana skin, it can be other last night meal that's not finished, or you throw everything, all the wet and dry waste in one bin. So with this, okay, definitely you need a sorter. So because now if you do it like manual sorter, okay, so what happened? So if you can actually sort out, you can segregate the metal from the household waste, it, the metal can be recycled back. So this is what we mean by circular economy. You want to recycle those things to make it more useful things. So you want to extend the lifetime of the product. So you don't want to simply use it for single time. So with the sorter, you'll be able to do this. So it's not just make the sorting more efficient. So it makes your the waste become more uh, sustainable. We say that. Okay, so we reuse your waste. So instead becoming just a waste, which end up in the landfill. I hope that answered your question.
Next question from the chat box. Salam Dr. Hajar, thank you for your sharing. Could you please share your views on the level of government support for IoT and smart engineering initiative in Malaysia, particularly in terms of current policies and funding, if such smart technologies are to be implemented in residential areas?
Okay. To be honest, okay, I'm not on the policy. Um, so I have no comments on that. I've reasoned my comment, but what I would like to share is this IoT smart cities, we are towards heading it, especially for Selangor. Selangor government really looking forward into to establish smart cities in the future, in the near future. So IoT is actually coming to everyone. Is not something new. It has been in the past years. IoT has been a very hit topic. So what I would share with all of you is that the current direction of the government, everything will be automated, especially with the AI coming in into the global, into everyone's life now. So everything will be automated. For example, I would like to share why IoT is so important. So, for example, have you ever, okay, recently we celebrated Raya, right? And then you went, okay, for those who live in Lembah Kelang, especially in Kuala Lumpur, you will know how congested was the traffic, and not just the traffic, the mall. Okay, so for example, UIA is very close to one of the mall, KL East Mall, for example. During the Ramadan, from the first day of the Ramadan, the KL East Mall has been so fully occupied, like full. Everyone's rushing to KL East Mall to buy, I don't know what, but it's always full. The parking full. In the weekend, they have to do a roadblock, like nobody can enter the mall. So what I can tell you with the IoT smart parking, okay, instead of coming, okay, so for example, you plan that, okay, today, in a day is today, Saturday, let's go out and go shopping at KL East Mall. And then when you arrive there at 12 p.m., suddenly you cannot enter because the parking lots are full. How devastated you are. Okay, so you travel 20 minutes from your home, you get ready, and then travel 20 minutes to the mall and found out that you can't park your car and you have to divert to another mall. So that's very frustrating, isn't it? But what happened if I tell you, okay, everything in your palm? You can check, okay, you can check the status of the mall. Are all the parking available, the parkings occupied, so you can check using the apps. For example, Smart Selangor apps, you can check using the Smart Selangor apps and then check, okay, so KL is more currently is fully, the parking is full. So, okay, let's go to another place. So you save your time 20 minutes traveling and also 30 minutes getting ready. So in total of an hour that you save. So this is how IoT actually would take I would say would take a good change to everyone's daily life. If we become more productive, we manage to uh, efficiently, I would say, that save time. Okay, so yeah, definitely IoT.
Thank you so much, Dr. Siti Hajar. Now we will move on to the next speaker. Our final speaker for today is Assistant Professor Dr. Muhammad Azri bin Abdul Jalil from International Islamic University Malaysia. Dr. Azri is an academic and researcher specializing in pharmacology, pharmaceutical science, and health sciences education with a strong interdisciplinary focus that integrates biomedical research, teaching innovation, artificial intelligence, and sustainability-driven applications. Dr. He holds a Bachelor in Biomedical Sciences and a PhD in Pharmaceutical Science from the International Islamic University Malaysia, as well as a Master of Medical Science pharmacology from the National University of Malaysia. His research centers on drug testing, animal model development, and advanced wound healing technologies, including biopolymer hydrogels, alongside interest in green drug delivery system. He is also actively involved in AI integration in education and healthcare, as well as initiative in planetary health and sustainable well-being, contributing to curriculum development, youth empowerment, and ethical AI governance at the institutional level. Collectively, his work reflects a commitment to advancing translational science, enhancing education system, and addressing pressing healthcare and sustainability challenges at both national and global levels. He will be sharing insights on AI for planetary health, predicting, preventing, and protecting our future. Assistant Professor Dr. Muhammad Azri bin Abdul Jalil, the floor is yours.
Okay, thank you, Camila, for your kind introduction. I will share my screen. Can you see the screen?
Yes.
Okay. Sorry. Sorry, this is some problem. Okay. Okay, Assalamualaikum, everyone. I believe you all enjoy listening to presentation from previous speaker. I really enjoy the talk about IoT and the application in planetary health. So today, this is my part. I would like to share with you a topic that is interesting about artificial intelligence for planetary health that focus on the predicting, preventing, and protecting our future. So I will touch a little bit about planetary health concept. Planetary health is founded on the fundamental principle where human health is inseparable from the health of environment system. We cannot be separated with our ecosystem. And then nowadays, a lot of issue occurs, such as climate change, biodiversity loss, and pollution can influence the disease pattern on the human, animals, and also it can affect our food security and overall well-being. So the big question is, can artificial intelligence help to protect both human and planetary health? Before further discuss on the artificial intelligence, I would like to give a simple differentiation between IoT and artificial intelligence. So here, IoT is like the eyes and the ears of the system, whereas AI is digital. It is a software and algorithm that function to think, learn, and predict. AI is like a brain that interpret what it sees and decide what to do. The neural network show here is not just storing data, it is engaging in decision making. The output of the AI usage is we can make a decision to act or to control the condition. Why? The question arises, why is artificial intelligence particularly relevant at this moment? There are two key drivers. The first is big data and predictive analytics. The available of large data scale nowadays include climate data, satellite imagery, and population mobility patterns can provide us a lot of information. In Malaysia, we have, for example, My Sejahtera and also Budi Madani. It is example of data that can predict or that can analyze the health condition of people in Malaysia and also the mobility pattern of Malaysia residents. And then next is the advancement of predictive analytics nowadays help us to transition from reactive healthcare to the proactive model. So what is a reactive to proactive model? So reactive model is the old model. On the left hand side here, we can observe the traditional reactive model where disease are treated after being diagnosed, and then it is often complicated after the disease have already developed. The flood response also initiated only after the disaster occurs. The disease outbreak are detected after widespread of transmission, and then limiting the containment effectiveness. We observe this during COVID-19 and influenza virus. And then biodiversity monitoring occurs after the population decline. So during this thing occurs, when this thing occurs, it is hard to recover, and it is more costly to control the condition. On the other hand, on the right side of the diagram, it presents a proactive AI-enabled model. So here we can see that AI is able to predict disease risk before the onset come. So from this we can provide preventive strategies to overcome the disease or to control or manage the disease. On the other hand, flood risk can be modeled weeks in advance, allowing preemptive evacuation and infrastructure protection. We also can identify outbreak before at the signal on the early stage of the outbreak before they can escalate into epidemics. And then for the biodiversity, we can track the biodiversity in real time to support immediate conservation action. This model is more to the anticipation rather than reactive. We can anticipate the disaster to occur and then take proper action. Okay, this is the main agenda of my lecture. My lecture is I would like to discuss more about predict, prevent, and protection. And then align with 4R framework. What is 4R framework? 4R framework is the real action in Planetiium, in our institute, Planetiium, where we introduce 4R: rescue, restore, resurrect, and reintegrate. So we would like to use AI in predict, in preventing, and also in protecting the planetary health and align with the 4R framework. The first one is rescue. We want to predict to rescue. We would like to predict to rescue, where we detect the risk earlier and enable immediate response. For the example for this can be for the flood. flood risk can be identified weeks in advance, and also we can predict or forecast the dengue outbreak during using climates and population data. For the restore, prevent to restore. Once the risks are identified, AI can support the preventive strategies that stabilize the system before damage become irreversible. In this case, we focus on the agriculture. For example, this AI can provide a precision farming that can reduce chemical overuse and thus preserve soil and water quality. The third one is resurrect. Okay, and then we use protect to resurrect. Protect to resurrect, we focus on the biodiversity. For example, we can use many AI model to help in conserve the wildlife, as well as using conservation biobanks, using AI to preserve genetic materials of endangered species. The last one is the integrate, where we protect to reintegrate the information. This is a crucial extension of the framework because it is not only technological, but it's also behavioral and societal, where the integration ensure that humans are not separated from the ecosystem, but are active participants in maintaining planetary balance. The first one is predict to rescue. So this slide shows how AI works as an early warning system by combining different types of data. First, on the left side, we can see AI collect multiple data sources such as real-time climate, satellite image, and also population data. From this image, it is then proceed using machine learning process in the middle. From the data, they being processed to produce the output on the right side on this diagram to show a risk map. This is the example of a demos in the Vietnam, where they can predict dengue outbreak up to 6 months in advance. This map help the researcher to identify high-risk area hotspot before the problem happen, and then they can take action such as a mosquito control or hospital preparation. Understanding how climate change may affect disease spread in the future. So AI can connect different data to see hidden patterns. Sometimes we as a human overlook the pattern, so we can act early instead of reacting late. In Malaysia also, we have a model similar with the demos in Vietnam, known as deep learning long short-term memory, LSTM, with a spatial attention. This is focused on the climate and population data mapped to localized hotspot prediction. Similar with Indonesia, they also have ensemble and Bayesian model. In Brazil, they use explainable AIs known as CatBoost, which is not only predict the outbreak, but also explain why, and then helping the authorities to make a better decision. So next one is the second one is preventing to resurrect. Okay, preventing is acting before the harm occurs. By using AI, we enable early intervention and optimization. For this, I focus on the food security. In Malaysia, for example, we can introduce urban farming and sustainable systems. The first one is fostering agricultural resilience. AI can play a vital role in strengthening global food security by supporting transition to regenerative practice and also reviving forgotten crops, also known as neglected underutilized crop species, NUS. So in this diagram, we have a few points such as precision agriculture, where AI can analyze the farm to optimize which fertilizer is suitable and which pesticide can be used to control the pests. And thus, it can prevent any chemical runoff into our river and ocean eventually. And then next is smart irrigation. Smart irrigation. Smart irrigation means that the algorithm can manage alternate wetting and drying to significantly reduce the water usage. And then third is reviving forgotten crops. We use AI model. We can use AI model to discover the benefit of neglected soils or crop species. And then the last one, climate resilient urban farming. I think this one being presented by Dr. Azhan about the urban farming system that are not really depend on the climate change. Okay. By integrating these technologies, we can create a sustainable system that capture carbon, protect aquatic boundaries, and restore the health to our soil. So this is the holistic regenerative landscape. What can happen if we focus on the resilient agriculture practice. So this is illustration so that it can increase crop yield if we practice the resilient agriculture model. We can recycle the carbon dioxide, can create a healthy soil system, and then it can create a good habitat for animals, for the wildlife, also as a pollinator, and thus increase the production of the crops. And also it can enrich the soil due to irrigation system, and also due to the reduced use of waste, eventually can improve the water quality surrounding the farm. Next is minimizing ecological footprint, as I mentioned before. If we can focus on the precision farming, we can reduce chemical harm by control the use of a pesticide and also chemical. And also by a smart irrigation program, we can conserve the water by alternating wet and drying system. And then lastly, in building the climate resilient urban and food infrastructure, where AI can precisely control indoor vertical farms to operate with near zero water discharge, where the water being circulated in the closed loop nutrient system. The other one, for the climate resilient urban and food infrastructure, the AI can be used to decentralize food supply chains. Why it is important to decentralize food supply chains? Because we want to reduce transportation. So we bring the food supply chains near to the community so that it can slash the transportation emission and also eliminate food waste. So we would like to empower the community with exact data on food origin, nutritional content, and environmental impact. This is known as farm-to-fork digitization. In Planetiium, we also have a practice. We turn theory into tangible practice through initiative like Eco Kitchen Garden, led by Dr. Aini. This project embodies our commitment to sustainable technology and innovation for food security, known as Sustain Research Cluster, by bringing food production lively or directly into our living space. Our practice focus on several key areas such as urban food resilience. We demonstrate that even small marginalized space can be transformed into productive system. Localized production, where we grow local such as cucumber, cherry tomato, and also we bring a sustainable system, simple and yet effective setup. Expanding our commitment to food security, we also implement the vertical aquafarming system. This initiative is part of our sustained research cluster, focused on several critical impact, where we integrate food system, we combining agriculture and hydroponic, allowing for simultaneous production of fish and vegetable at the same time. And also we circulate the resource by using vertical space and smart water cycling. And also this model can bring a good economic and nutritional benefit because we can get a fresh source of protein and also source of nutrient. So through VAS, Planetiium is bridging the gap between innovative technology and real-world community empowerment. We also focus on community, where we also include the marginalized community support. So here, through marginalized community support, we implement the aquafarming system to enable community to enhance local food production. They don't rely on the current condition of the food supply and empower themselves with sustainable food resource. Also in Planetiium, we have a living lab known as Biosphere Courtyard Basic. So this living laboratory showcase a permaculture, regenerative agriculture, and organic farming in action. So here we focus on the soil and crop rehabilitation. We focus on biodiversity conservation, integrating farming techniques such as alley cropping, perennial circle, silvopasture, napier field, and also we produce a few stock such as rabbit, goat, and cows to harmonize livestock with crop production. Through the Biosphere Courtyard, we provide a practical model for how diverse ecological system can be integrated to foster long-term planetary health. We are looking forward to integrate the local tradition practice with AI-driven technology to optimize the outcome in the future, inshallah. So next one is biodiversity protect to resurrect. So this for this protection, we focus on the biodiversity protection, consists of wildlife monitoring and ecosystem tracking. For the wildlife monitoring, we also monitor global research to refine our conservation strategies, such as this study on abundance estimation of unmarked animal based on camera trap published in the conservation biology. So they use camera trap data to count wildlife without needing a physical text. So here, the key takeaways from this picture, from this diagram, they use a methodological framework, compare several models such as site structure models, random encounter models, and distance sampling to estimate the density across different terrains. So by this, they know exact amount of the biodiversity available on the real time. And then they use the time-lapse photography and precise distance sensor for more accurate collective view sheet estimation. And then they can estimate animal movement and also specific distance measurement. So this is important for monitoring elusive species in their natural habitat, as shown in this capture from remote camera trap. Okay, this is the animal we can see from the remote camera trap. And also we can observe the animal using the facility. For example, here, this is artificial canopy bridge. We can see the bridge here. It is for to help the primates to cross between this bush or this forest. We don't need to crossing the road on the ground. This can reduce the motor vehicle accident for the human as well, for the animal. So how we want to monitor the effectiveness of artificial bridge by providing the chemical trap. And this picture was taken from Brazilian bush rural countryside in the Rio de Janeiro. So next, the using of eDNA analysis. So in the wild, AI can be our eyes and ear. We can use this eDNA analysis to detect species just from the genetic material left in water or soil. The genetic material such as skin, saliva, or waste can be sequenced by using this AI application. So here, this is the example how the eDNA analysis we can assume, we can recognize which type of wildlife available in our surrounding. Another application of AI is anti-poaching and autonomous surveillance. So here we can use it to reduce the poaching of the valuable wildlife by using the application of UAV, unmanned aerial vehicle here, such as drone, to become our eyes to observe the condition of the animal, the wildlife, and then we can use artificial neural network ANN here to become the ears, where from this ANN we can hear any poaching activities. For example, if there is a gunshot, this ANN can detect the gunshot for the authorities to take the action. And then CNN is the brain, where they can identify and count the animals like elephant, for example, while simultaneously distinguish between the local authorities, the forest ranger, and the poachers. In basic Planetiium, at Planetiium, we already put our effort for the conservation, where we deploy camera trap to observe or to predict the animal available from our surrounding, and it is the first step toward the conservation process. So here we can see there are 3 steps in the conservation of ecosystem. We have a macro one, meso, the camera trap, and the micro. Micro is focused on cell lines and conservation biobanks. So here, AI can be used for the micro conservation. For example, we can use automated cell growth monitoring, and also we can use automated genetic screening. So the automated cell growth monitoring in conservation bank, we can use example CytoSmart model. It is non-invasive. You can continue monitoring what is inside the incubator, and the advantage of this, we can reduce the contamination risk. So it doesn't mean that we need to open and close. It can cause the contamination. So by using this CytoSmart, we can reduce the contamination, and also we can provide support for the fragile of this cell. Usually this conserve this animal cell, this energy animal cell it is more sensitive. So it is not robust. So by using the CytoSmart, we can reduce the contamination and increase the chance for survival for this cell. Another thing is we can use it for cell proliferation analysis. It can be used to doubling the time, and also can increase the cell proliferation rate. This is important because the cell can be grow exponentially, and also we can detect any abnormalities or senescence in the cell. This approach has been used on the African savanna elephant to improve the storage of the cell. And then next is we can use automated genetic screening. This is more advanced, where we can detect any abnormality in the chromosome. We can use metaphor software, where we can detect any metaphase spread in the chromosome. And also this can replace a slow and subjective manual search. When we use automated metaphase, genetic screening become more faster and reliable, and also can be scalable for conserving the endangered species. At Planetiium, we have frozen zoo. The main focus of frozen zoo is to protect the genetic diversity, to produce a biobank to store the cells, to preserve using cryopreservation, and then from this cryopreservation we can create cryostability of the genetic diversity. So this is the facility we have in the Planetiium. The last part is protect to reintegrate. The integration is not just about ecosystem, it is about people. So here, program like Earthlink initiative at the IUM, they connect individuals with the planet, ensuring sustainability become part of daily life. When we combine AI through data awareness, environmental monitoring, and digital tools, program like Earthlink can scale the impact from individual behavior to system-wide change. So here in Earthlink, we plan to educate the student, the young people on planetary responsibility, and we encourage them to live a sustainable living practice at the early stage. This can bridge the knowledge. It can bridge the knowledge towards the behavior. While this tool is powerful because we can achieve high audience engagement, making this global challenge feel more personal and immediate. Because this method is effective because it can show real-world application. It can bridge the key domains, which are technology in AI, education, behavior, and sustainability. So this can elevate from theoretical to actionable, where instead of just learning about the problem, we empower the people with tools and mindset to take real-time action. I would like to share about the digital twin Earth. Okay, as we know that we only have one planet, and there's a lot of poster that we only have one planet. But interestingly, with AI, we can create our twin planet, twin Earth, digitally. So it means that we can create a model to replicate the Earth, and then we can estimate or predict what would happen if we continue doing this type of activity, what will happen on the Earth on by using digital twin Earth. So by using data stream one, which is prediction, prevention, and protection, we can get the good insight uh, where we can deploy a simulated intervention based on this digital twin Earth. So it is like a flight simulator, but for planet Earth, it can allow humanity to rehearse, respond to pandemic, for example, pandemic, to famines, and ecological collapse in a safe virtual environment before making before translate it into the real world decision. Okay, I would like to end my presentation with this quote. The future of health is no longer just clinical, it is planetary. And artificial intelligence is the bridge that connect them. That's all for me. Thank you.
Thank you, Dr. Muhammad Azri, and thank you to all our speakers for their excellent and thought-provoking presentations. Now we will move on to the next Q&A session. Participants may unmute your microphone and ask directly or via the chat box. Let me read through the chat box. The first question is, thank you, Dr. Azri, for the sharing. What is your opinion on the effort of our relevant government ministries, such Ministry of Agriculture and Food Security of Malaysia, Environment and Forestry, in integrating all these smart technologies in their governance?
Okay. Do I need to answer first or waiting for all the question? I answer first, right? Okay. Thank you, Susila, for your question. Actually, I'm not the right person to answer this because I'm not from the government. But from my observation, what our government does nowadays, our government really support on this planetary health. As we know that we have national planetary health action. So we focus on this area, and what we call the food security is part of the planetary health. And then the government uh, also what we call create or categorize the IoT these things as a critical agenda. So and then the government really support with giving a grant, matching grant, especially because matching grant, when we collaborate with industry, we know the real action, what happened in our industry. And also the government further support through mostly on the integrating my STE 10 by 10, and smart technology is part of the STE, my STE 10 by 10, where we really encourage our people, the resident, not only researcher, the community, to apply the smart technologies. So this is our future of farming, sustainable farming or smart farming. The government really looking forward for any farmers through many authorities to integrate any technology to improve the crops, the yield of the crops. because nowadays we know that the Minister of Agriculture also they encourage all household to what we call to promote the agriculture practice on their courtyard. So I think the effort is good, but it can be improvised in the future. Okay, Sila.
Okay, for next question, how can IoT-based solutions for planetary health can be designed to actively engage and motivate individuals and communities to participate in sustainable practice?
Yeah, this is quite challenging because we would like to see how people to practice the sustainable practice. Okay, yeah, it is easy to say about this practice, but there must be a lot. This is why we uh, organize this program. So we would like to give we call the awareness to the society, to the individual and community to participate in sustainable practice, because only this small effort can be lead to the higher leaps, higher steps. Okay, so IoT based solution, because as we know the IoT is expensive, it is not cheap to apply IoT. I think to answer your question, maybe the government should give, for example, tax exemption or what we call loan, sometimes zero interest loan, for example, like using the EV. So EV cars, EV vehicle, electric vehicle, the government encourage the use of the EV vehicle by imposing tax exemption. So I think for the sustainable practice, maybe the government or authorities can give some things, incentive to support the individual or community to participate. Okay.
Okay, for next question, Salam Dr. Azri, thank you for your sharing. In your personal view, how should we balance innovation and caution when deploying AI in planetary health initiative in view of the potential misuse of AI by humans?
Okay, thank you. Thank you. This question is so RUM. Yes, it is good. Yes, AI is a good tools, but if we did not use it properly, it can be dangerous or hazard tools. So this is important. The ethics. So I think maybe on the different topics we can talk about ethics on using AI. So and first we talk about ethics. It is the individual, what we call individual effort, individual awareness, and the other thing is regulation. Regulation for local authorities or especially the government. So maybe in the future the government can enforce the AI related authorities to for any innovation, for example, or so that the AI usage can be controlled without can cause uh, without affecting other communities. If, for example, it is like using of antibiotics. So if we did not control the using of antibiotic, it can cause public health. So maybe there will be enforcement by the local authorities so that any potential AI innovation that can cause it can affect public health can be prevented. Okay. Yes, interestingly, there is no if I'm not if I'm mistaken, please correct me. But for now, we don't have any law specific law, but we are going forward to that on the AI under the Ministry of Technology. So we are currently collecting data on the policy, on the potential usage of AI. So far, we don't have a specific, but now we are collecting the the information on that.
Thank you, Dr. Azri. Before we bring this webinar to a close, we will proceed with a brief photography session. I would like to request everyone to open your camera for photography session. Okay, we will wait for everyone to be ready. Okay. 1, 2, 3. Okay, one more time. 1, 2, 3. As we come to the end of today's webinar, I would like to once again express our sincere appreciation to our distinguished speakers and to all of you for your active participation. We hope this session has provided valuable insights into smart technologies and IoT from scientific, health, and sustainability perspective, particularly within the Southeast Asian context. Before we conclude, please be reminded to scan the QR code currently displayed on your screen to record your attendance and receive your e-certificate. Additionally, to stay updated on our upcoming peace webinars and other initiatives, we invite you to follow Planetium's official social media platforms. Thank you once again for your time and continuous support. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh, and have a pleasant day ahead.
Okay, thank you everyone. Assalamualaikum.
Assalamualaikum. Thank you, everyone.
Thank you all. Assalamualaikum.